Good afternoon everyone. My name is Praneeth Bankar and in today's video we are going to discuss about a data structure called stack. Now in this data structure we are going to discuss about its basic how does a stack work and about its FIFO first in first out principle and even about its and further moving forward about its two basic algorithms or two basic operations called push and pop. We are going to discuss what does it mean and also its we are going to understand the logic behind its code of push and pop functions of a stack. So let's move on. With its data element value stored in various nodes. Now these nodes are connected. These nodes have two parts. One where the data element is stored, and is a other is a pointer to the next node in the linked list. Like this node is connected to this node using this pointer. So suppose here is another value. So this node will be connected to another node, and so on. There is another value, this node is connected to this node using the pointer. Now once we reach the end of the linked list, suppose there is a end value of this linked list, then this pointer to the next node will contain null value. So as it is the last element, it will not point to any other element in the list. So this is basically what linked list is. Linked list has the major advantage of as it doesn't need to store elements in a contiguous array. Like for example, in array the elements are stored in a contiguous format in a memory. Like if the memory starts from here, the next element shall always be here, here. It shall be in a contiguous form which restricts some operation and tasks. In linked list you can add any element from anywhere in the memory. Just connect those elements using the pointer to the address of the next element. So this is one of the most basic advantages of a linked list. Now in linked list there are two types of linked list. There are basically three more types of linked list, but we will discuss about three. Actually majorly only one linked list, but let us understand what these three types of linked list are. Types of linked list. Now there are majorly three types of linked list. First is singly linked list, singly linked list. Second is doubly linked list, and third is circular linked list. Now what is the difference between these linked list? Now going forward with singly linked list is basically a linked list with the node of the with the linked list which has only one pointer. Like this pointer is pointing to the next node. Now the pointer of this node is pointing to another node, pointer of this node is pointing to another node. Suppose this is the last element, this pointer has null value at its last. Now this is an example of singly linked list. Although but thus in doubly linked list there are two pointers, which one pointing to the previous node and another pointing to the next node. For example, this is a doubly linked list. Here is the element value. Now here is one pointer pointing to the previous node that it had, and this pointer is pointing to the next node that it will have. Like the basic advantage of doubly linked list is we can perform insertion or deletion operation from any end of the linked list. Like we can insert from here and delete from here, as there are pointers pointing to both previous as well as the next element. In although in singly linked list we can only insert or delete from one end, as the pointer is pointing only from one direction to the other and only to the next element in the list. And in circular linked list it is basically that whenever we reach the end of the linked list, suppose this is the last element of the linked list. Now as we have seen before, the last node of the linked list is always set to null. Even in doubly linked list, whenever we go to the last element next pointer is set to null and the first element previous pointer is set to null. But in circular linked list, the last element's pointer is connected, is set to the header, to the header node, the first node of a linked list is known as its header node. So in circular English, the last link, the last pointer of the linked list is set to the first node of the linked list. This is basic. This is the basic difference between the three types of linked list. So before moving forward, let us again revise and understand why is linked list important and why is it more efficient. So again, in data structures like array, whenever for example we have an array of 1 2 3 4 5 6 7. So this array elements like 1 2 3 4 5 6 7 are stored in an contiguous way in the memory. Like if there is there is memory, this is suppose the memory, it starts from 2000 2004 2008 all the way to 2020, I guess. So this. So these numbers 1 2 3 4 5 6 7 are stored in a contiguous manner, like 1 2 3 4 5 6 7. They can't be stored. They can't be stored in any other way other than a contiguous manner. But in data structure like linked list, we can just like first create the header node with element 1 and then use it pointer to point to any memory location. Like this must be this may be 2000 and this must be 4000. Doesn't matter. We will just have to give the address of this location to this pointer and we'll link them both, and we can store the element 2 in this pointer. We can move forward with pointing this node's link to another pointer to another location, like for example 3000 or so, any location. So basically we can point from one node to another and store elements in a data structure in any location in the memory, which is quite efficient compared to any other data structure. Now let us move on to our last part, and which are the operations we can perform on a linked list. Now we will discuss about operations we can perform only on singly linked list. Now in singly linked list, we can perform operations like insertion and deletion. Now insertion. So let's move forward with insertion. In insertion we have three options, which is first insertion from beginning, from end, or from anywhere. So first, insertion from beginning. For inserting an element into a linked list from beginning, we have to take that element and we have to point the pointer of that element to the header of the previous element. So for example, if we have an previous element linked list of 1 2 and 3, and we have to insert 0 in this linked list, so we'll take 0 and point its pointer to the header, which is 1 of this node, and move on forward and keep it the same and keep the rest of the array same as before. So this is how we insert from beginning in a single linked list. Now from end, when it come to from end, we will keep the header as it is 1. Let's take an example 2 3. Then after this pointer of 3 is null before we insert the element in the linked list. So let us assume we have to insert the element 4 in this linked list. So first we have to traverse the whole list to the last element in the list, and then point the pointer of the last element, remove the pointer from null to point it to the location of the element we have to insert in. So for example, in this case it is 4, and then point the pointer of the fourth element as null, so this element becomes the last of the list, and hence the insertion from end is successfully completed. Now, when it comes to insertion from anywhere, it is basically just traverse the list till the point we have to insert the element. Like for example, let's take this list 2, 4, 5. Now, in this list, suppose we have to insert the element 3 here. So we'll just we'll traverse the list till the till a position before we have to insert the list. So we'll traverse the list till here and point the pointer of this node to the new node we have to insert, which is 3, and point the pointer of 3 to the node which was pointed to by 2. So basically the 3 is added between these two pointers, between these two nodes, which is basically addition, insertion of an element from anywhere in the list.